man, alright, so this was, I've done a lot of bikes, and I gotta tell you, man, this Project F3 that I picked up is just turning out to be an absolute nightmare with electrical problems. And overall, the bike runs really well. My frustrations are the electrical issues seem to be going from the stator to the rectifier, creating a problem, burning wires, all sorts of craziness. So as you can see, I've got the original stator pulled. Currently, I've got a new one over there, but you know, before I moved on and just started connecting everything, I wanted to check stuff because there were enough burn connectors that this was very problematic. And I'm like, you know what, if I'm going to do this, we're going to do it right the first time. So I wanted to make this video, and if you want, I'll upload it to my YouTube channel, so there'll be a completely separate thing from here in case this video gets lost in translation, you know, back in time. Over time, posts just disappear. I will upload a separate video just for you guys. I wanted to show you how to test diode and forward and reverse bias on a system like this. So first thing you need to do to check your rectifier on a 3-phase on the F3s through, you know, 98. This will probably work for the 900RR. I mean, this is most likely going to work across the board for most of you guys that run 3-phase rectifiers. But so you're going to come down here and put it on your diode setting. That's going to be the one with the little arrow on the plus. Okay, and what we're going to look for is going to feed a slight amount of electricity through the system, basically, is what's going to happen here. So we're going to test forward bias first. So what we're going to do is find the negative or the positive side, and we're going to put the negative terminal on there. As you can see from the multimeter, I have the negative on there. We're going to go across the 3 phases, and we should have a reading. And they should all be pretty standard readings. So I'm going to start with the furthest one here, and they should all be pretty close. This is within tolerance. Let me make sure this is settled on there good, so there's a good connection. As you can see, all reasonably well within tolerance. That is doing exactly what it's supposed to. Now that is testing forward bias or positive bias. What we're going to do now is we're going to check reverse bias by doing negative off, positive on. And this might take me a second to do because I have to rearrange some wires. Doing this with one hand is definitely not the ideal scenario, guys. If I had to be honest with you, it's just the only way I can do this right now. So let me add some forward pressure so that it keeps a little pressure on the pin, and then I'll try not to knock that around. So now we're going to test negative. Now here's the thing with negative, okay? So once again, I put the positive on the positive. What we don't want is power feeding through the system on negative bias. If I get any kind of reading other than 0 or 0.1, or I'm sorry, 1 point, then there's a problem with this rectifier. So I'm going to go across the 3 phases again, and as you can see, I'm getting a reading. Not just on one, but all of the pins. This rectifier is shot. So I went ahead and marked it so you guys can see plus, negative. I had to go to the bike to figure out which side was which by putting the multimeter on the wire scheme. But that is how you essentially test a rectifier to know if it's pushing power. Power should only go one way through a rectifier, and that's it. So just to be clear about that, right? AC should not be coming out the other side of it. It should only be DC current. So this rectifier is no good. That is a quick way to diode check a rectifier, a 3-phase rectifier on your bike. So that is forward and positive. I'm sorry, positive bias going forward, you should have a reading. Negative bias going backwards, you should not have a reading. You should not be getting reverse currents, right? That means AC is flowing through DC side. That's very problematic for your machine, considering these things run 50 to 60 AC volts, right? And you're only requiring 12 to 15 to run the bike, and that's DC. So not good on your system at all whatsoever, which is why you end up with stuff like this, fucking dramatically burnt connectors and just ridiculous stuff going down with your bike. My suggestion to all of you is check your rectifiers regularly. Check your wires, disconnect them and have a look. Clean your terminals, right? Clean these things very well. Dirty contacts and terminals create resistance, and resistance creates heat, and therefore these things heat up and then they burn out components. If you're not regularly cleaning these, like probably I would say 6 months to a year, and replacing your rectifier probably every year, you know, you have a huge chance of fire on your hands and burning out your entire electrical system on these older bikes. You know, there are ways to bypass this. You can direct wire this, but then if you have a serious problem, the only option that's going to happen is that this will catch fire with direct wiring, right? If the fuse does not blow, this will catch on fire while you're riding, and this is underneath your plastic, so good luck getting to it. So I've never been a huge fan of direct wiring these things. There's a reason why they have connectors and stuff, so they can burn out instead of the bike catching on fire. I'd rather have a connector burn out than direct wire this and have this thing catch on fire while I'm riding. But hey, you know, a lot of people do weird things. So hope this video helps, man. I'll post my YouTube channel below. I have a whole ton of videos coming for this bike that I've been working on. Some of you guys have been following it, some of you haven't. I basically bought this F3 for what, $1,000, and it's just been a fun project, but is clearly having a lot of electrical issues. So I'm gonna have to figure out how I want to move forward from here. I would rather not direct wire if I can help it, but if I don't have a choice, you know, I'm not going to replace the entire wiring loom on the bike. It'd just be way too time consuming, and I have too many medical conditions to go that far, dropping engines and pulling things out to get the wiring loom out to replace it due to electrical issues. But I think this is solvable as is, but that's all I wanted to show you guys, was how to do a rectifier. So now you guys should understand forward positive and negative bias, and how to test a 3-phase rectifier on your CBRs. Anyways, I fixed it. I'm out. Toodles.
Are you sure this is okay? You're in country, dude. Live a little. Now, she's pretty sensitive, so go easy on the throttle, okay? All right.